So this first track is around structured design. There'll be a separate track out there for object-oriented design, but you really probably should look at both of them because they're both interesting. This will be the kickoff. There'll be a number of them out there. You can skip around as you want to, come back to it as you want to, but you'll kind of make a choice here. My recommendation is after you've looked at both of them and which ones you're going to build. You don't have to do certain elements of structured design, but even if you're looking at this track, you will have to look at certain elements of the object-oriented track to be able to get everything that's required out there. So just setting the context up there for the work you're going to do. So the core of structured design is really around analyzing data flow. We want to see the inputs that are coming into a system and the outputs that are going out for a system. And really every computer system can be broken down into inputs and outputs. If you think about it, if I'm playing a video game, I'm hitting WSAD on my keyboard or up, down, left, right on my gamepad, and I have stuff that's going on screen, inputs, outputs. If I'm trying to fly an airplane for real, I'm probably moving some stuff around on the cockpit, and then the engines speed up or slow down or whatever they're going to do. That's fly-by-wire if airplanes, the new modern airplanes. So any system, whether it's real-time embedded or whether it's completely virtual, or heck, even computer, it's even easier actually if you don't have any people involved at all, because then you have some files coming in and some files going out and some internet coming in and some internet going out, and you can clearly see inputs and outputs from that standpoint. So all systems can be broken down to that. So if we can document what the inputs are and document what the outputs are, we've really captured what my system does. And that's what we do in structured design. We have this process called functional decomposition. Now, in functional decomposition, we use this flow of data. We use this flow of data of what are the inputs and where does it go as the outputs, and break down what are the steps that get from there. So if I think of some high-level process, and we will think of that quite a bit here, how do I break down the high-level steps that get us from point A to point B? And we'll come back to this notion, but the idea is by refining this model, we're going to better understand what's going on. Before we get to that point, though, is we have to know what our system does. And so within the requirements, we got the big level features of what the system's supposed to do. Those analysts, whether they're business analysts or system analysts or software analysts or just analysts, whatever they are, their role is to go through and say, what are those big functions? And all those functions that the system's going to be going through is going to be capturing information in the requirements phase. And so in design, what we want to do is better model out those functions, those features. They may or may not come with diagrams. They may just come with words, bullet point lists that says, hey, this is what our system does. And so what we want to do is start by modeling out that single functionality, that one piece of the system, and going to break it down from there. Now, the way we break this into this little piece of functionality is we use something called a context diagram. So the context diagram sets, surprisingly enough, the context. Typically, a context diagram can be as large as the entire system. So let's say I'm going to have a system that has websites and admin sites and web services and iPhone applications and Android applications and Windows applications and batch jobs and all this great stuff. Well, somebody has to go through and define for that what are all the pieces, what are all the inputs, where are things coming from. So even though I have all those pieces of the system, what do I get inputs from? What humans are involved? What systems are involved? So for instance, I could be looking at the prices of items people want to sell. And where would I get those inputs? Well, an input could be from eBay. Maybe I call some service on eBay, or I do screen scraping of their websites to see what are the prices of similar things. What are the outputs? Well, I could be sending money through PayPal to people's bank accounts, or I could be creating a file that gets printed out as a report, or I could be just creating screens that entertain people. All those things have to be considered from the system. But the context diagram could be, the system inside of that could be more refined. So let's take a moment and look at the notation before we give an example of this. Because the context really means a process, something that we're about to construct. It could be the whole system. That's a process. It does a bunch of stuff. It could be some piece of that system. Could be something like, hey, I'm going to focus in on just, as we are in a minute, the Android application part of it. It could even be smaller than that. It could be like, okay, I just want to worry about the one feature where the user inputs data for buying stuff or selling stuff, or they're going to one piece of that. And we want to talk about for that one piece, what we'll later on call a use case. We want to define what are the involved external entities. Who are the people giving us inputs? Who are the systems giving us inputs? Where do we send data to? What systems, what people are receiving that data as outputs? And so the boxes form the external entities that the system is going to interact with. And then the data flow is shown by these lines. And the line is very specific here. Notice it's a straight line, completely filled in, no dots, no dashes, with an arrow at the end. This notation is important. In all software diagramming, notation is important because it means something. If I see a dotted line, it means something else. We'll see that later on, actually. So we want to make sure we draw these arrows perfectly if we're going to go off and use this notation. So before we leave the idea of a context diagram, let's look at an example. So as we said, we're going to look at an inventory and a management app for Android. And so the idea of this inventory management application is users log into this and they have some configuration, which is who are they, what sort of color do they like their screen that comes up, and things like that. So we have an inventory, a user management aspect of our inventory system. Now, since we set the focus on our Android system, the external system is a box. Now, in the whole light of things, I'm building the Android application. Well, Judy up the aisle from me, who sits on a different desk, might be the one who's writing the web services that allow me to get to the user management. And maybe Dinesh around the corner is the one updating the database for Judy that's doing that. So we're all part of the same team. But for what I'm building, the Android application, that's external to me. It's the user management system that gives me. I send it some data, it sends me some data. Separately, what am I doing in my inventory management? Well, I'm going to allow users to go around and take photos of stuff. And they're going to be able to upload those photos and descriptions of the items and how much they bought them for and sold them for. This is actually an application I thought about building a few years ago because I have had this massive Star Wars collection, and I wanted to be able to inventory it and maybe sell it off and get into buying and selling. Well, it turns out that I decided just to sell the whole thing off anyway. It was a little bit easier to do that. Big one block. But anyway, I had this application, so I had this idea for this collection. So I had this idea for managing my collection. So this is like maybe, as I said, an eBay helper application, something that people can manage their inventory through that. And maybe they get prices from eBay or they can list it automatically to eBay. But that could be an external box here, like some connection to eBay. But I'm not worried about that right now. My context diagram is telling me what I am worried about. What am I going to design right now? So the big thing for my application, I need to be able to log in, get some user information, and I want to be able to do additions and updates to existing collections, which I pull back from my user inventory system. And so the important thing I've defined here is that I have a lot of external data. I'm not storing much on my application. There's not a lot happening locally with data storage, but I'm providing a conduit to store those things elsewhere. Now this helps define the system moving forward, and that's what we're going to do moving forward is how do we design the system in more detail. But this context focuses us into which requirements we're solving for, and then what are the general approaches towards what do we think we need. If somebody comes by and says, hey, you forgot the eBay requirement, well, maybe I need to add an external box here. Or maybe I say, you know what, that's phase 2. But that's part of that conversation we talked about earlier that we have around design. And so by drawing it here and creating this diagram, this model, I'm starting that conversation. I'm really able to then tell a story with the diagram plus some words, either written down or verbal. But remember, for academic purposes, we always have to draw a picture and then tell the story with words. So we'll continue on from here, but take some time and consider your context diagram for the rest of your design pieces for what you're going to be able to turn in to make sure you are telling the story of which part of the system are you building.